Hello and welcome to this lecture on complex integration. In this video, we are going to see about Cauchy's integral formula and related problems. So, first of all, Cauchy's integral formula is integral over C f of z by z minus a n plus 1 dz will be equal to 2 pi I n factorial f power n of a, where f of z will be an analytic function. Here n denotes the derivative. Okay, so if f of z is an analytic function inside and on the given closed curve C, then we can evaluate this integral part by using this formulation. This is, we call it as Cauchy's integral formula. Okay, so first I will list the steps. How do we solve this? Procedure. Step 1. Find the given curve. So this is our curve. So of course we want to find this curve by using the formation z can be written as x plus iy. And second step, find the poles. Okay. The third step, if the poles lie inside C, then use Cauchy integral formula. If it lies outside, then we use Cauchy integral theorem. That means the integral over f of z dz will become 0 over the C. Okay. So we will use Cauchy integral formula if the poles lie inside the C. Then at last evaluate the integral. That's all. These are the 4 steps. Okay. So first I am taking out the given region and I will substitute the value z equal to x plus iy. So I have substituted it, and then I am splitting up the real and imaginary part separately. And we know that the modulus of x plus iy will be a square root of x square plus y square. So here this becomes square root of x1 plus 1 square plus y minus 1 whole square equal to 2. And if I bring the square root to this side, then I will get the equation x square plus 1 whole square plus y minus 1 whole square equal to 4. So of course this will be the equation x minus h whole square plus y minus k the whole square equal to a square. So this gives the equation of circle with radius A and center will be h comma k. So from this equation, here radius will be 2 because a square not 2 square will be 4 and center will be minus 1 comma 1. Okay, so now we find the region. What it will be? A circle minus 1 on the x-axis. Here it will be of minus 1 and here it will be plus 1. So if I take this as minus 1, this as plus 1, so here it will be 1. So I will get the circle with radius 2. I am drawing it roughly. Now solve the poles. So how do we solve this pole? We have to take the denominator of the given function and equate to 0. So if I equate to 0, then I may use the quadratic formula. It will be of z equal to minus b plus or minus square root of b square minus 4ac by 2a. Here the value of a will be 1, b will be 2 and c will be 5. While substituting it and after the evaluation I am getting it minus 1 so plus or minus 2i. So while substituting those values b square will be 4 and 4ac it becomes 20 and I am getting minus 16. So square root of minus 1 will be imaginary. So I am getting the final value as minus 1 plus or minus 2i. So now we find the value minus 1. So here from this z1 will be plus 2 roots will be there, no? So z2 will be minus 1 minus 2i. Now we want to check whether it lies inside a circle or not. So let me check whether it lies inside a circle or not. So our equation, the given curve will be z plus 1 minus I equal to 2. So instead of z, I may substitute the z1. So it will be minus 1 plus 2i plus 1 minus I. So plus 1 minus 1 will get cancelled and there will be I. So this will be simply 1. So 1 is strictly less than 2. And if you take here instead of z, I may substitute z2, then minus 1 minus 2i plus 1 minus I. Here again plus 1 minus 1 will get cancelled. Minus 2i minus I na minus 3i. So if I am making over the square, it will be of 9. 9 is greater than 2. So it lies inside, it lies outside. Okay. So then what we have to do? If it lies inside, we have to follow the Cauchy integral formula. So our general formula will be like this: integral over c f of z by z minus a whole power n plus 1 dz will be equal to 2 pi I by n factorial f power n of a. See, In this Z1 lies inside the circle. What about Z2? It lies outside. So, according to this formula, we want to find the f of z. What is our f of z means? Which the pole which lies in outside the circle, we have to we have to consider that remaining terms. This pole lies inside the circle. This pole lies outside the circle. So I may take this as f of z. Okay. So now this is equal to this expression. So now I may write z plus 4 by z minus of minus 1 minus 2i divided by z minus of minus 1 plus 2i. It is of power 1. So we get the expression like this. Here how it will be integral over c. Here it will be of dz. So we can write this term like this. So I'm getting the left hand side of the Cauchy integral formula. So here it is n plus 1, here it is 1. That means n will be 0. If here n will be 0 na, what will be on the right hand side? 0 factorial, and f power n. N I say that n will be the derivative. If n equal to 1 na, we have to go for the first derivative. Here n equal to 0 na, simply the given function f of a. Okay. If n equal to 1 na, it will be first derivative. N equal to 0 na, there is no derivative. There is no derivative na, simply take the function f of z, substitute the value z equal to a. That's all. Okay. So from this I am getting this equation. Just see carefully. I have taken the f of z one side and the remaining term 0 factor will be 1. So I may take the 2 pi I to the this side, then it becomes 1 by 2 pi I integral over c. F of z will be this and z minus a, where a will be minus 1 plus 2i as per our consideration. So what we have to do to evaluate this? We want to find f of a. That means we need f of z. Then you have to substitute the value z equal to a. So that's what we are doing next. So f of z will be z plus 4 by z minus as per our consideration. What I took as on the last page, z minus minus 1 minus 2i. I am taking the same z minus minus 1 minus 2i. Okay. So at the simplification I am getting this. On the next I have to substitute. We need f of a, where a will be minus 1 plus 2i. So I am substituting it. So I am getting f of a. So in this expression I am substituting the value z equal to minus 1 plus 2i. Wherever it is z, I have to substitute this value. Then I will get the final expression as 3 plus 2i divided by 4i. And I'm just multiplying them I, because in the denominator there is a imaginary part, so I am multiplying a imaginary value both numerator and denominator for simplification purpose, and I'm getting that 2 minus 3i by 4. On the next, what I told you that the general formula will be integral f of z by z minus a whole power n plus 1 dz equal to 2 pi I. Here n will be 0, simply 1. So what will be there in the next? 2 factorial, 0 factorial, then f of a. We find the f of a already. So to evaluate this, here we want to multiply the f of a with 2 pi I. So this is our f of a. We multiply with 2 pi I. So finally we get the answer as pi by 2, 2 minus 3i. The next problem. Here, as same as the previous thing, what we will do, we will take the given equation and we will substitute the value z equal to x plus iy, and then we will simplify this. At last, we get the expression x square plus y plus 1 whole square equal to 1. The center will be 0, x minus h, so h will be 0, and minus k, so minus 1. So this will be the center and radius will be 1. And we want to find the poles by taking the denominator of the given function. We will find the poles, so the poles will be z plus 1 minus plus and minus I. So clearly they are saying that minus I lies inside the circle. How it is possible? What is the given equation here? Z plus 1 plus I equal to 1. Right, let me take Z plus I equal to 1. I may substitute the value plus 1 I instead of Z, because Z1 will be plus I and Z2 will be minus I. There are two roots for it. So here what will be the value? 2i. So if I make the square, it will be a 4. 4 is greater than 1, so definitely plus 1 Z1 equal to plus 1 can't lie inside. That means which lies outside. If I go for Z2 minus I, what will be there? Minus I plus I. Okay. So if I take this Z equal to minus I, it will be of 0. So definitely less than 1. So it lies inside. So Z2 minus I will lie inside the circle. On the next, we want to, of course, it is a factor. This is the given function z by z square plus 1. So I am taking the given function, and this can be factor because plus I minus I, so it can be written as z minus z1 into z minus z2. So z1 will be plus I and z1 will be plus I, z2 will be minus I. So these are the factors, and I am taking this minus I lie inside, minus I lie inside na? So this lie inside the circle. So z minus I factor lies outside, so therefore I am taking this as f of z. So here it comes f of z by z plus 1 plus I. Okay. On the next step, what we will do, by using the same formula, integral over c f of z by z minus a whole power n plus 1. Of course here it will be of 1, so there will not be any derivative, equal to 2 pi I by 0 factorial. Here it is 0 because here it is of 1. Then f of 0, na? There is no derivative on a, we want to find only f of a. Okay. So f of a will be minus I. You already we derived the f of z here, z by z minus I. You just substitute the value of a equal to minus I. Then at last you will get 1 by 2, and then you have to multiply the value. F of minus I is 1 by 2, so you just multiply here to get the final value pi I.